So in this video, we're going to learn how to find the magnitude of a vector. I've got a vector here. It's 6i plus 8j. I'll start by drawing in the horizontal and vertical components. We've got 6i there. And we've got an 8j going up top. Okay. Now to find the magnitude of this vector, we just have to use Pythagoras' theorem. So I'm going to redraw this triangle here. I'll just do it in white to save some time. So this is exactly the same triangle. The only difference is that I haven't drawn in the arrows here, so I'm not looking at the vectors in this triangle, I'm just looking at the lengths, right? So we've got 6 there, we've got 8 there, and that's our unknown. Let's just call it v without the tilde. So to find the magnitude of this vector, we use Pythagoras' theorem. So v squared is equal to 6 squared plus 8 squared, right? Which is equal to 36 plus 64. If you add those two up, it becomes 100. That's v squared. So v by itself will be plus or minus 10. So the reason I've included the plus and minus is that whenever you're doing this, so whenever you're taking the square root of something squared, the answer could be plus v or minus v. I'll make a video going more into detail about this later. In this case, however, because we're talking about the length, the length is always positive. So we can reject the negative 10. So we have to say that. So reject v equals negative 10 since the length is always positive. Okay, so therefore v is equal to 10. And when you're doing a question like this, you don't have to go through all this working. In fact, you can just go straight to the formula, and let's try and do that. Let's try and generalize a formula out of this example. So instead of 6i and 8j, what if we had just some number x for here and some number y for here, right? So if we had xi and yj, right? And these could be any numbers you want. So we'll get rid of that 6 and the 8. Same here, this just becomes an x and y. And you can probably see where this is going, right? So we've got x there, y there. So again, we're still going to use the Pythagoras' formula. The only difference here is, I'll just do this down below. So what's going to happen is we've got v squared is equal to x squared plus y squared, and v becomes positive x squared plus y squared. Okay? Again, this positive is because the length is always positive, so we reject the minus 10. Otherwise, normally it would be a negative there as well. Okay, and when you're doing questions like this, you can just go straight to this formula and use that. You don't have to show this reasoning at all. This is just what I've included to let you know where this formula comes from, because it's important to understand that as well. You know, you don't want to just blindly substitute numbers into a formula because that defeats the purpose. So I've included another example down below, and here you can see I've just subbed in the values into the formula, because now I've understood where the formula comes from. I can just substitute what I want in there. And the purpose of this example is just to show you that, you know, even if you had a negative, so if in this case we've got negative 4i and negative 2j, the negatives will become positive once you square them, so the length will end up being positive, right? So the length is always positive.